Let's take a look at another application of finding relative extrema of multivariable functions. Please pause the video, go ahead and read the problem, read it again, figure out what it is it's asking us. All right, this last statement is telling you what you need to do. You need to minimize cost. And they're telling you that cost is this function. So we want the minimum of that function. It does have two variables, but that's okay. We know how to do that with the DTest. So we're going to find the partial derivatives, the first one with respect to x. So from the first term, 10x squared, we get 20x. From the second term, y is a number because we're taking the partial derivative with respect to x. So 2y squared goes to 0. Minus 40x gives us minus 40. 240y goes to 0. 22,000 goes to 0. Now we can find the second order with respect to x. And on this one, y is a number again, only we're coming from here. And when we do that, the derivative of 20x with respect to x is 20. 40 goes to 0. Now we need the mixed one. For this guy, with respect to y, x is a number, so we're coming back up here again. So the derivative of 20x is 0, and the derivative of 40 is 0. And so the second order mixed is 0. Let's go ahead and take the first order partial derivative with respect to y. For this one, x is a number, so we go back up to this original function with respect to y. The first term, 10x squared, goes to 0. Second term, 2y squared, goes to 4y. Minus 40x goes to 0. Minus 240y goes to minus 240. This is the derivatives, right, with respect to y. 22,000 goes to 0. So now we're going to find the second order partial derivative with respect to y. And on this one, x is still a number. And we're going to come here to this guy. When we do that, 4y goes to 4, 240 goes to 0. Find the mixed partial. We know we're going to get what's above, but let's go ahead and just verify that. For this guy, y is a number. So the first term goes to 0, the second term goes to 0, so the derivative mixed is 0. Save this information. Here it is written down for us. And the next step, so the first step, we did that, find the partial derivatives. Now we're going to solve the system where each of these partials is equal to 0. 20x minus 40 is equal to 0. And this first derivative with respect to y, 4y minus 240 is equal to 0. When you do that, let's on the left-hand side add 40 to both sides. Divide by 20. So x is 2. So we have this so far. On the right-hand side, add 240 to both sides. Divide by 4. Y equals 60. Remember, sometimes when you're solving these two equations and we got a system, that you'll have to actually substitute one in the other or do elimination. But on this one, since each of the first order partials only have one variable in them, you're just going to get numbers. And so that works out really nicely. This is our candidate critical point for a possible extrema. So we bring all that information together. We have all our derivatives here, partial order derivatives. We have our critical point here that we're going to test, and we're going to test it here in the DTest. Now in the DTest, we have these second order partials. They're all numbers, so we don't have to do any work. We're just going to substitute. That means D is equal to 20, C sub y, 4, minus the mixed squared. So we get 20 times 4, which is 80, and that guy is greater than 0. That means that we have to, now we have to check the second order partial derivative with respect to x. We have c sub xx is equal to 20. That's greater than 0, which means this, which means we have a min. So this guy is a relative minimum and a minimum cost. We pull all that information together, and our fourth step is typically find the z-value, but on this problem we don't have to do that because we only need to know what x and y are going to minimize the cost. Now go back to the original problem. X was stated as the number of days of skilled labor, and so this guy here, 2, is the number of skilled labor, I can't say that, labor hours, and 60 is the semi-skilled. So you do have to use that information in your final answer. So let's go ahead. You need 2 days. Oh, and days is written there. 2 days of skilled labor. And you need 60 days of semi-skilled labor in order to minimize the cost. So again, where did these titles come from? Here, for the x and y values, they came from the original problem statement. So that's it. Hope you're having a great day.